Hello there and welcome back to my new video. With this video I'm starting a new tutorial series about room database with Kotlin. This tutorial series will have 5 videos, and this current video will be all about creating a database schema for our project. So if you have watched my earlier tutorial series about SQLite Database, then you noticed how hard it is to create and manage one database. But with Room library everything is easier. Room library is built on top of SQliteOpenHelper class, and the main advantages of using Room library are compile time verification of SQL queries. So each query and entity annotation is checked at a compile time, which prevents your application from crashing at the runtime. At the compile time it checks also not just the syntax but missing tables as well. Next advantage is less boilerplate code, and it's easily integrated with other architecture components like live data. So there are 3 main components of Room database. The first one, entity. So entity represents a table within the database. Room creates a table for each class that has entity annotation, and the fields in the class corresponds to columns in the table. Therefore, the entity classes tend to be small model classes that don't contain any logic. The second one is DAO, or data access object. DAOs are responsible for defining the methods that access the database. In the initial SQLite we use the cursor objects, but with Room we don't need them, and we can simply define our queries using annotations in the data class. And the third component of Room database is a database. It contains the database holder and serves as the main access point for the underlying connection to your application data. Okay, so this is how our application should look like. It will have 3 fragments. The first one for listing all our data, the second one for adding the item to our database, and as you can see, when we add that, it will show up in our list fragment, and we can add for example one more item. And when we click on one of those items, we're going to get navigated to our third fragment, which is update fragment, and from there we can update our data, or we can delete our item from the database. So let's update that, click update, and as you can see the value has changed. So now we can also delete that, or we can delete everything from our database, and it's simple as that. Okay, so before we start with the code, we need to add all necessary dependencies for our project. So you just need to copy all the dependency which I have added already. So we have navigation component, the room, lifecycle component with ViewModel, and we have Kotlin components for coroutines. Okay, so all those dependencies will be available for you to copy from this video description. Next, don't forget to add compile options and Kotlin options to target Java version 1.8, and also check your plugins. So you need to apply exactly those plugins which you see right here, and minimum SDK version should be 26. And in this different Gradle file we will see this navigation safe args which you need to add as well. Okay, so now that we have added all dependencies for our project, we can start and create a database schema. So as I mentioned earlier, in this current video we're going to create a database schema. So first we need to create a new package, and I'm going to name this package data, and inside this package we're going to create a new Kotlin class. We're going to name this class user. So this user class will represent an entity inside our database, inside our Room database, and as I already mentioned, entity represents a table within the database, and this is just an example of how our user table will look like. Okay, so first we need to make this class a data class, and we need to add some fields to this class. So first I'm going to add the ID of type integer. So our class will have 4 different fields. Okay, so ID, first name, last name, and age. So the ID will be a primary key, and it will be automatically generated by a Room library. So next we need to annotate our class with entity annotation, and here we need to specify a table name. So our table name should be named for example a user data, okay, or maybe user table. And now that we have specified that, we need to add a primary key as well. So above the ID we're going to add the annotation primary key, and here we're going to specify auto generate to true. That means that room library will automatically generate the numbers for our ID column. Okay, so our entity class is finished. Next we're going to create a DAO. So let's create interface, because DAO needs to be an interface. We're going to rename this to user DAO. Okay, so I have already mentioned what DAO means. It means data access object, and basically it will contain all the methods used for accessing the database. And inside this interface we're going to create all the necessary queries which we're going to execute inside our database. Alright, so first let's annotate our interface with DAO. Alright. And here we're going to create a function add user, and we're going to pass our user entity here. So let's annotate our function with insert, and here we're going to specify on conflict strategy, and in this case it will be just ignore. So that means if there is a new exactly the same user, then we're going to just ignore that, but you can specify a different on conflict strategy. And I'm going to add a suspend keyword in front of this function, because we're going to use coroutines later in our tutorial series. And next we're going to create another function named read all data, and it will be the type of a list of users, and user we have already created this user model, and it will be wrapped around the live data object. Okay, and here we're going to annotate this with a query. So here we're going to create a custom query. So we're going to select all the items from the database. And to do that, we need to write SQL query, something like select all from user table, which is the name of our table, order by ID ascending order. Okay, and it will return a list of user wrapped in a live data. So don't worry if you're confused right now. Everything will make more sense later in this tutorial series when we continue working on that. So for now we're going to have just two queries for inserting the data and for reading the data. Okay, so next one we need to create our database. So inside this data package let's create another class named user database. So our user database class will represent a database in a room library. So a database basically contains the database holder and serve as the main access point for the underlying connections to your data. Okay, so we need to add the abstract keyword in front of this class, and we need to extend the room database. Okay, after that we need to annotate our class with database annotation. Okay, alright, so inside this annotation we need to specify entities. So we have only one entity, which is a user class, and as a second parameter here we need to specify a database version, which is 1, and we are going to set the export schema to false, because the export schema default value is true. And if you're wondering what is this export schema, so basically it's telling you that it is a good practice to have a version history of your schema in your code base, but I don't need that at this moment, and that's why I have set that to false. Okay, and basically you can check every keyword here within that documentation by pressing and holding Ctrl Q, so you can read more about them. So now inside this class we're going to create a function or abstract function which will return user DAO, or our data access object, which we created already. Okay, so next we're going to create a companion object. So everything within this companion object will be basically visible to other classes, and we want to make our user database singleton class. So what does it mean, a singleton class? Well, that means that our user database will have only one instance of its class. And next inside we're going to create a volatile variable named instance, and we're going to set the instance initial value to null. What does it mean, this volatile? So basically it means that writes to this field are immediately made visible to other threads. And down below we're going to create a get database function. As a parameter we're going to add a context, and it will extend a user database. So inside this we're going to add a variable named the temp instance, and we're going to assign the instance to that new variable. So in this block we're checking if this temp instance is not null. So basically that means if our temp instance is not null, that means that our instance already exists, and basically we are returning that instance. And inside this synchronized block we're going to create a new instance if our instance is null. So what does it mean, this synchronized block? Well, it means that everything within that block will be protected from concurrent execution by multiple threads. And in this synchronized block, we're basically creating an instance of our room database. So we're passing the context, our database, and the name of our database. And we're assigning the instance with this new instance, okay? So that's how we have created a singleton for our room database. So let's repeat one more time. So as you can see, inside our companion object, we have our instance variable, and the initial value is 0. And in this getDatabase function, we are checking if this instance is not 0. That means if our instance already exists, then we are just returning that same instance. And otherwise, in the synchronized block, we are creating a new instance. So if there is no instance, then we are creating one. And if there is an instance, we're just returning that same instance. And we're always using the same instance for a room database. That's really important to remember, because having multiple instances of room database is very expensive for the performance. Okay, and next what we're going to create a repository. So inside this data package, create another Kotlin class with the name of user repository. So what is a repository? So basically, a repository is a class that abstracts the access to multiple data sources. The repository is not the part of architecture components libraries, but it is suggested to be a best practice for code separation and clean architecture. So you don't have to use the repository, but it is always a good practice to do that. So we're going to add one parameter here, and that is our data access object, which we already created. And here we're going to create a variable named readAllData, and this variable will be a type of list of user, all wrapped inside the live data object, okay? And basically we're going to read that data from this user data access object, and we're going to create a function here named addUser. As a parameter, of course, we're going to add the user, and we're going to use this user data access object to access our addUser function from our user DAO. And this function will have a suspend keyword in front of that, because we're going to use coroutines in ViewModel later. So now we're going to create that same ViewModel, and from this ViewModel we're going to access all our queries from our DAO. So if you're wondering what is ViewModel, so ViewModel's role is to provide data to the UI and survive configuration changes. ViewModel acts as a communication center between the repository and the UI. So again, if you don't know anything about ViewModel, I already made a video so you can inform yourself by watching it. Okay, so this class will extend the Android ViewModel, and Android ViewModel is different from a regular ViewModel because it contains application reference. Okay, and here we're going to create a variable named readAllData, and it will be the type of list of user, all wrapped in the live data object. And next we're going to create init block. So init block is always first executed when user ViewModel is called. So here we're going to create a variable named user DAO, and we're going to use our user database to get the database. And as you can see, we're passing application here as a parameter, and we're accessing our user DAO from our user database. So next we're going to create a repository variable, and inside this init block we're going to initialize this repository, and we need to pass one parameter in a repository, and that is user DAO. So we have already created this user DAO, and we also need to call this readAllData from the repository. And now down below we will create one more function to add the user. So for now we only have methods to readAllData and add the user, but later in this tutorial series we're going to add more of those functions. So here, as you can see, I'm using a ViewModel scope, which is a part of Kotlin coroutines, and I'm using this dispatcher IO, which basically means that I want to run this code in a background thread. So I'm using this addUser function from the repository, and I'm going to run that in a worker thread or a background thread. So coroutines are very useful, and it is always a bad practice to launch database jobs from the main thread. So you always always want to run them inside the background thread instead. And that's it for this video. We have created our database schema, so we have our entity, we have our user DAO, we have our database, we have a repository, and we have a view model. So everything is ready. And of course, this project link will be available for you to download in the video description, so you can check that out by yourself and compare with your own code. And in the next video, we're going to start by inserting the data in our database.